In this Sequoia demonstration, we'll take a look at the bookmark system of Sequoia and the point region of interest. Let's first create a point loader with a dataset containing over 300 million points. It was provided by LabCLAM from Sweden. We'll expand the scanner data and we'll see that there were 14 scanner positions. We can set the orientation to the plus x-axis instead of the scanner rotation, since otherwise it points down. And we'll create all 14 bookmarks from these scanner positions. At this point we can enable auto-update, and if we switch to any of these bookmarks by clicking on it, the view will be updated to look from the position of the scanner. And we can orbit around and set the bookmark to the updated view in order to adjust the direction in which we are looking. We can do the same for the second bookmark. We'll look in the direction of the bar where the Buddha statue was in the previous bookmark, and we'll update again. Now if we switch between these two bookmarks, we're going to get the new updated views. You'll see that the density of the points is not very high, so we can increase the limit, point limit set to 50, and we'll set it also to 50 in the point loader. Both have to be changed in order to update the viewport to that amount. And now we see that the density of the points is much higher, but of course the loading also takes much longer. So we can probably switch to 20 million points for the viewport. And if we want to get rid of the gaps between the points for preview purposes, we can just switch to the viewport settings and adjust the point size. Make the points a little bit bigger. We can enter by hand 5. And we have the choice between circular and square shapes. But square look actually better for architectural scans. So we can repeat the same, go to any of the bookmarks and adjust the views and update the bookmarks to the updated view. And here we are in the kitchen area, and there is a storage room next to the pantry where some bottles of Coke and Sprite are stored. So let's move to the scanner that is placed just in front of this room, and we'll try to isolate this area with a point region of interest and mesh only this area. So we press T to switch to the top view, and then we can add a point region of interest while the point load is still selected, and this will connect the two. If we click the button Fit View Clipping, this will adjust the point region of interest to match the top view that we had set up. So now it's very easy to just curl the extent that we're not interested in and define the area that we want to test for meshing. We'll have to switch the orthographic to perspective view, and this is the point cloud section that we'll be working with. With the point region of interest selected, we create a mesher, and the mesh actually suggests a relatively large radius because the density of the points is quite variable in this area. And this is of course not enough. As you can see, it's very rough and the detail is not there. So we can try 0.5 centimeters, which automatically changes to 5 millimeters in the display. And we can remesh again. This time the meshing will take a little bit longer, but the detail will be much higher, and the vertex colors of the resulting mesh will also contain a lot of the detail of the point cloud colors. This is still the points, so we can hide the points in the viewport and then wait first for the vertex cloud to appear. Here it is, and then the faces will be updated. At this point we can take a look at the wireframe display, and we'll see that it's pretty dense. So we can try to use the reduced option to set it to 10% and update. Since this is going to take approximately a minute to calculate, I will pause the recording and we'll wait for the processing to finish, and then I'll return when it's done. Here it is. We can now take a look at the wireframe of the reduced mesh, and the polygon count is obviously much lower. We can set the current value, the 10%, as a temporal preset and switch back to the default with auto update on, and this will load the previous mesh straight from cache without remeshing it again. And if we wanted to go back to the 10%, we can just select 10 from the list, and we are automatically back to the 10% without remeshing. As you can see, we were able to determine a good radius value based on this. Let's save the scene so we can continue later from the same data set and with the same settings. Now that the scene is saved, we can come back later and perform a hacksaw meshing on the whole restaurant using the measure radius that we just determined on just a small region, which saved us a lot of time.